Hello, welcome back. Hello friends, hearty welcome to you. We are just solving some simple examples of linear equations in one variable algebraically. So let's look at this example. We have 2x minus 2x by 5 minus 14 by 3 less than 7 by 21. So I have to find out the value of x. Solve this inequality means I have to find out the value of x, all the values of x which will satisfy, which will make this particular statement true. Okay, right. So what I have to do first now, I have term containing x and next to that I have some other term, so I should get rid of it. It is minus 14 by 3, so I should make it 0, so I should add 14 by 3. So my next step will be, I will say 2x by 5 minus 14 by 3, that should be 7 by 21. Now I have to add 14 by 3, so I will add 14 by 3 on both the sides. Now when I add that, these two will cancel out and 7 by 21 is nothing but equal to 1 by 3, and you have 14 by 3 here. That's a typo there, let me just fix it. That's 1 by 3 plus 14 by 3. Okay, so next step will be, we'll just simplify this. We'll have 2x by 5 less than 1 by 3 plus 14 by 3, that's nothing but equal to 15 by 3. So the next step is, I have term containing x with 2 by 5, but I want only x. So what I should do, I should multiply by reciprocal of this coefficient of x so that I can make x equal to 1. Now you know that you want to make a number equal to 1, you should multiply it with its reciprocal. So what I will do now is, my next step will be, I will write 2x by 5 and less than 15 by 3 here. I have to multiply with 5 by 2. So I will say multiply with 5 by 2 on both the sides. We have to do it on both the sides. When I do that, 5 cancels, 2 cancels. I am left with x is less than 15 into 5 is 75. Okay, I can say 3 5 times, so I'll have less than 25 by 2. X less than 25 by 2 is the solution of this inequality. Now x is an integer. If x is an integer, then the solution set will be, it cannot be less than 25 by 2, so it cannot be 13, but it can be 12, and all the integers before 12, 12, 11, 10, you can have 0, then you can have minus 1, then you can have minus 2, and go on. So that's about the integers. If it is real numbers less than a positive real number, that means you can go till there are no other constraints. So negative infinity to 25 by 2, that's 25 by 2, and open bracket, because it cannot be equal to 25 by 2. It's a strict inequality. Okay. Now let's take one simple example and see whether it works out or not. Let us say 12. 12 is very simple. So if I substitute 12, what happens here? 2 into 12 is 24 by 5 less than, what we got is 5. You can see that 24 is less than 25. You can do cross multiplication too. You can say 24 into 1 less than 5 into 5, 25. 24 is less than 25, so that solution is correct. Now let's move to here. 4x minus 2 less than or equal to 10. So the same way I have to do. What I have to do first now, I have the term containing x is 4x term, and I have minus 2 next to it. I should avoid it. So I will say 4x minus 2 less than or equal to 10. I have to avoid that 10, so that means it's minus 2. I should do plus 2 so that it will become 0. Remember, a number you want, when you are multiplying, you want to make it as a reciprocal. You want to make it as a 1, you will multiply with reciprocal. Whereas when you are adding or subtracting, you want to make a number equal to 0, then you will go for, you will add the inverse of that. Okay. So 4x minus 2 plus 2 should be equal to less than or equal to 10 plus 2. Now this is nothing but equal to 2 cancels out. I'll have 4x less than or equal to 12. Now I have term containing x and the coefficient is 4. I should get rid of 4. So I have to divide by 4 now. So I will say 4x divided by 4 less than or equal to 12 by 4. So when I do that, I will have 4 cancels out one time. So I'll have x less than or equal to 4 again 3 times. So x less than or equal to 3 is the solution. So if you take x equal to 3, you will have 10 equal to 10. If you take x equal to 2, you will have 6 less than or equal to 10, which is perfectly fine. Now if x is an integer, how it looks like? I will have 0, 1, 2, 3 also included, because you are saying less than or equal to 3, and you will have all the negative integers from minus infinity. If x is a real number, then less than or equal to 3, that means from positive number you are going to the opposite direction. So I will say minus infinity comma 3 is also included, so I can go and say closed bracket, which says that the boundary here, the 3, is also included in the solution set. That's about couple of examples we have solved. In the next session we will look into another type of examples. We are going through linear inequations in one variable, and we are providing the algebraic solutions. In the next session we will look how to represent the solution graphically. That means it's a one dimension, so it will be on the number line how you will put down the solution, which you are already aware of, but we'll just look into couple of examples into that. Thanks for visiting. Bye for now. See you again.